So my screen is visible to you, okay? So shall we start?
Yes, sir.
So yesterday we solved an example on the design of your voltage connection. So in that case, we need the formulas for strength, capacity, and shear. That is VSB is equal to SVB divided by under root of 3 into gamma MB, then an ANB plus NS ASB. Okay, NN is for the shear at the threaded portion, and so that we are because threaded portion is not total gross area or plane area, that's why we are considering with the NS this net area. And net area generally we are taking for this voltage connection 78% of the plane area. Then if there is the friction dipole or if the plane or shank area is there intersecting the thread, intersecting the shear plane, then in that case the NS value is for the plane area or shank area you can say. Shank area is nothing but the plane area. So therefore it is related with the plane area, that's why NS into ASB. Okay. So in mostly if you are using the common bolt or rough bolt or black bolt, so they are fully threaded. So if the bolt are fully threaded, so this term will not exist and it will be zero. Okay, because there is no shank area in the fully in the black bolt, in the common bolt, in the round bolt, you can say. So that's why there is throughout the thread portion. That's why only threaded portion will be there. And only this portion of the formula will be applicable. Then gamma MB is the partial safety factor for the board material. We are taking from the table number 5 of IS4. And similarly, NN is equal to number of shear plane intersecting the thread portion. And NS is number of shear plane intersecting the plane portion or shank portion. Okay. A and B the net area of the board, you can find through the formula. And T is equal to diameter of board. And A is the plane area of the board, that is 5 and 400 degree square. Similarly, bearing strength of board we have to find, and that is VDB. VDB is given 2.5 times of KB, D into T into FU by gamma M, MB. All this, FU is ultimate stress of the plates, gamma MB the partial safety factor for the material, T is the thickness of the thinner plate, thickness of thinner plate is the T. Okay, and B is the diameter of your board, nominal diameter of board, and KB is the minimum of PS4 value, P upon 320, P upon 320 minus 0.25, FUB over FU, and is 1. P4 value, which was the minimum, you have taken. And how to find out the thickness of plate, it is explained in this example, and today also you can able to understand. Then tensile strength of plate is the third uh, your tensile strength of plate is nothing but your it is given in your IS code. TDM is equal to 0.9. And A is the net area, and net area is generally P minus ND0 here because we are finding the per precedent here. So it is 0.9 A FU upon gamma M1. The net area of plate is P minus ND0 into T. And then design strength of bolted connection is the minimum of VDSB, VDBD, and PDM. So all these three, which one is the minimum is the design strength of bolted connection. And a bolt value or strength of bolt is nothing but it is a minimum of VDSB or VDBD. दोनों में से जो भी नियम रहेगा, bearing strength of bolt or shearing strength of bolt, that will be the bolt value or the strength of bolt, you can say. Then number of bolt, if you have to find out, if you know the force or load on the member, you can put the force divided by the bolt value, and you can easily find the number of bolt required for the connection. The strength of unbolted plate, if you have to find out the efficiency, then the strength of unbolted plate is known. Here in place of AN, we have to take AG, and because in tension only we are considering the 90% strength, that's why we have 0.9 AG FU, where there is ultimate strength, there is FU and gamma M being the partial safety factor for the plate material. Then efficiency of the voltage connection, that is represented by eta, and eta, that is efficiency is nothing but the strength of voltage connection per incident, which we have find out here at number 4, and divided by the strength of unbolted plate, which we have find at number 7. So this 4 by 7 value into 100, you will get the efficiency of the bolt in percentage. So this we have seen, and then one example to find out the bolt value or strength of bolt. We have done yesterday, and today you will check you will see another example. This is the lap joint. We will see today the fourth joint with another example, and you can find out the values of your or whatever you are in that. So write down the example number 2 for your today's lecture number 10. Okay. So today is the lecture number 10. So I will take some. Okay. Well, what's time now, Piniti? You should join the lecture on time. And I request the student they should open their camera if they are, so because I will come to know your word writing. Okay, so this is the lecture number your 10 at region of lecture number 9. You are already. Subject is your favorite subject 301003, and today is 30 July 2002. Okay, we will solve the example here. Write down the example and sit with the pen, paper, and notebook and calculator. Also with your eyes closed. If you are. So write down the single bolted double cover joint. Single bolted double cover butt joint is used to connect two plates of thickness, two plates of thickness 8 mm. The thickness of core plate is 6 mm, or the thickness of core plate are, because two core plates are there, 6 mm. Use 16 mm nominal diameter of bolt of grade 4.6. 4.6. It is visible. It is visible. I am writing.
Yes, sir.
Okay. So use 16 mm diameter bolt calculate 4.6. Calculate strength and efficiency of joint. Calculate. Sorry. Calculate strength, and efficiency of joint. Efficiency of joint. Where the pitch is given, take pitch is equal to 14 mm. And grade of steel is given, or plate is 18410. Okay, so this is given example. Okay, so I will write down the solution for that. You should also write down. Okay, so I will read the example you have written also. Single bolted double cover butt joint is used to connect two plates of thickness 8 mm. The thickness of cover plate is 6 mm. Use 16 mm diameter of bolt, and a small d is given 16 mm. Okay. So therefore, as per IS code, you know that D0 is equal to D plus clearance. Okay. Clearance in IS code it is given IS 800 2007 page number 73. Yesterday I was shown to you. So when you come to the page number 73, so you can find the clearance for the 16 mm bolt is 2 mm. You can see here 16 to 22 mm bolt, the clearance will be minimum 2 mm. Okay, so we will write here the clearance is 2 mm, so D0 is equal to D is the 16 plus clearance 2 mm, so D0 is equal to 18 mm. Okay, this is given, and then the diameter of bolt is given, and the grade of bolt is also given. The grade of bolt is grade of bolt is equal to 4.6. So therefore, the ultimate strength of bolt will be that is FUB is equal to what I have told you. You have to take the first value 4, and then it has to be multiplied with the 100. Ultimate strength will be 4 into 200 is 400 Newton per mm square. Okay. Similarly, you can find out the FYB. FYB is nothing but, so to take this second value, so in this 400, so 0.6 into 400, we get the FYB is 250 Newton per mm square. Okay. When pitch is already given, pitch is equal to 40 mm. It is already given in the example, and you can easily find out. Ahmad, what is time? Daily you are joining the lab. So you can pitch and end distance you can find out E is equal to 1.7 times of D0. 1.7 times of D0 is you already find over, that is 18. 1.7 into 18, it is sometime 30.6 mm. You can round it or you can use as it is, depending on you. Okay? You want to round it, you can round it. If you don't want to round it, you can go for that. Or you can round it or maybe write 32 mm. Okay, it depends on you, E value. Okay? So now this is your second page, chapter number 10. Okay, so all these given values we can find out. Now what here asked in example, what you have to find out. Here you can see that what you have to find out. Here calculate strength and efficiency. So strength and efficiency, strength of joint हो रहा है. Strength of joint is nothing but minimum of VDSB, VDPB and tensile strength of plate. Okay, per pitch length. So you have to calculate these three, and then for efficiency you have to calculate the bolt, this is strength of unbolted plate also, because the strength of bolt, strength of joint divided by strength of unbolted joint, you have to divide to find out the efficiency. So all the formula you have to use what we have discussed here in the previous lecture. All this formula you have to use, 7 parts you have to use and you have to take. So we will start first with the shearing strength of bolt, that is BDSB, and BDSB is equal to BDSB is equal to FUB upon root 3 into gamma NB in bracket N into ANB. Because the another term AS into ASB is 0, because it is the grade of bolt is 4.6 and 4.6 grade bolt is nothing but is a common bolt, and common bolt is not, it is fully threaded. It is fully threaded, so there is no plane area. Okay. Now here, when you have to know the value of Nm, you should know the shear plane. So what is given in example? Two plates, okay, of 8 mm, 8 mm thick. Two plates of 8 mm thick. You are joining with the two cover plate. Okay. You are joining with two cover plate at top and bottom. Okay. Gap नहीं रहता है, okay. And single bolted है, singly bolted है, तो both side single bolt is there on members. Okay, so this is the pole at one plate and another plate, and it is divided by two cover plates. The thickness of cover plate is 6 mm. है, both cover plate thickness is 6 mm, and thickness of main plate is given, it is 8 mm. So both plate having thickness of 8 mm. And since both joined, so both plates are touching each other and joined the cover plate. Now here you can see now here you can see how many shear plane is there. Anyone? Now you can see here how many shear plane. This is one and this is another. है ना? Here also this is one. This is another. So how many value of NN? So here the value of NN will be how much? बोलते रहिए. This is the classroom. The value of NN will be 2, because how many shear planes are there? Here 2 shear planes are there. Okay, this one, this is. Or the area, the NB net area is nothing but 78%. That is 0.78 times of plane area. Plane area, if you find out, the goal is circular, so pi by 4 into d square. Okay, you can find out A and B. So A and B is equal to 0.78 into pi by 4 into d is 16 square. So A and B will be, you have to find out by calculation. 16 square into shift of your pi equal to divided by 4 is the area of 4201 into 0.78, 28%. So it is coming some around 156.8, 156.83 mm square. Okay, this is that area of the book. Now you know the FUB, you know the gamma NB, so you have to put the value VDSB is equal to 400, FUB you have find above, divided by root 3 into gamma MB is 1.25 into NAN is 2 into area of ANB is 156.83. We will get the value of VDSB is equal to 156 into 2 into 400 divided by in bracket root 3 divided by 1.25. We'll get the value VDSB is 57,948.7 Newton. So we'll get the VDSB value is. We can see that VDSB is equal to it is 57.94 or 95 kilonewton. We are calculated in units. Now we have to find out the bearing strength of pole VDPB is equal to this formula you have seen yesterday. Is also given the IS code. You come to the IS code, this formula is already given. bearing capacity of bolt VDPB is equal to 2.5 kVdT divided by FU into FU divided by gamma. And we write here this formula is 2.5 into kV to D into T into FU divided by gamma E. Okay, this is the formula. I will write down all the values, but here kV you don't know. The kV is you have to find out. First we will take E upon 3d0. So E we have taken here 32. We have calculated E here. Okay, this E you have calculated here. So E is you are taking 32. You can write E is 32. 3 into D0 is 18. You can find out 18 into 3, 54, 32 divided by 54 is 0.5. 0.5. So this is first value. Now you find out second value is P upon 3d0 minus 0.25. P is given 40 mm divided by 3 into 18 minus 0.25. You solve this, you will get 3 into 18 is 54. 40 divided by 54 will be 0.74 minus 0.25. It is coming 0.49. 0.4907. Okay, this one is the second value of kV. Then you have to find out third value of kV is FUB upon FU, and that is equal to FUB is 400 and FU is 410. So 400 divided by 410 is 0.975. 0.975. This one is your third value, and fourth value is 1. Fourth value is 1. So above all these four values, which one is minimum? You can say this one, the second value, is the minimum of all the values. The second value is the minimum of all the values. So I will take this value as a kV. So our kV will be now fixed. The kV will be 0.49. Okay, you can take 0.49 or 0.4907, whatever. So this kV value is fixed. Now all other values in formula you know. D you know, T you know, F you know, gamma and you know. Now here what is the value of T? So you know this is the plate is connected with the two core plates. Okay. So here you can see this 6 mm, how much? 6 plus 6 is 12 mm. And the one main plate is 8 mm. So which one is minimum? 12 or 8? Definitely 8 is minimum. So T is nothing but 8 mm. So here the value of T is, let's say, 8 mm. I will write the value of T is equal to, the value of T is 8 mm. अगर सिंगल कवर रहता तो वैल्यू ऑफ टी क्या रहती आपकी 6 mm रहता है ना, क्योंकि 8 larger 6 less. Okay, now we will write down here the VDPB is equal to 2.5 into kV is 0.49 into D is 16 mm into T is 8 mm into FU is 410 divided by gamma NB is 1.5. All these values fit and then solve, you will get the value 2.5 into 0.49 into 16 into 8 into 410 divided by 1.25, you will get the value 5151430 0.4 Newton. And if I will write in kilonewton, VDPB is equal to 51.43 kilonewton. Okay. Now you have to find out the tensile strength of your plate. Tensile strength of plate, the third formula TDN is nothing but is equal to 0.9 into AM into FU divided by gamma M1. Now what is the AN? AN हमने पहले आपको बताया था AN is equal to P minus ND0 into T. So if you see here, the pitch of bolt is nothing but distance between the two holes, center to center distance two holes. अगर ये दो होल हम अगर लेते हैं, that is the pitch. Okay? तो यहाँ पर P, ये हाफ होल हो गया और ये हाफ होल हो गया. तो ये क्या हो जाएगा? P हमारा है 40 minus N. N is 2. D0 is D0 plus D0 by 2. हाफ इधर का, हाफ इधर का. Into thickness of plate is here 8 mm. So, equal to, to find out this, the value of AN will be 40 minus this 2 will cancel. D0 is 18 into 8. So 40 minus 18 is 22 into 8. That is 22 into 8 will be, it is coming 176 mm square. So that area of per pitch length, it is coming 176 point. Put all these values, you will get the value of TDN. The TDN I will write here is equal to 0.9 into AN is 176, FU is 410, gamma M1 is 1.25. The gamma M1 value you can take from table number 5 of your IS code, page number 29. So come to the page number 30. You can see here the gamma 1 resistance or governed by the ultimate stress is the value is 1.25. The partial safety factor for ultimate stress is 1.25. If yielding or buckling is there, then it is 1.1. So this table number 5, on table number 5, you can take this value. Gamma M1 is 1.25. The TDN will be now. I will write 0.9 into 176 into 410 is equal to divided by 1.25. It is coming 51955. So this is 51955. Newton. If I will write in kilonewton, it is 51.95 or 96 kilonewton. So now we know the value of VDPB, VDSB and TDL. So we can judge the strength of joint. है ना? The strength of bolted joint is minimum of VDPB, VDSB and TDL. So strength of joint, strength of bolted joint is minimum of VDSB, VDPB and TDL. तो TD ने अपना है 51.96, VDPB हमारा आया था 51.43 kilonewton. All values are in kilonewton, we are converted. And VDSB हमारा आया था 57.94, I think so. VDSB is 57.94 kilonewton. So here first value you can calculate and you can know here the minimum of all these three. VDSB 57, is 51.43, 51.9. So this value is the minimum of all the value. The strength of bolted joint for pitch length is this value. That is 51.43 kilonewton. 51.43 kilonewton. Okay. Now, what you have to find out? Here the example is not finished. There is two parts in your example. First part, you have to calculate the strength of joint, and second part, efficiency of joint. So to find out the efficiency of joint, you have to find out the strength of unbolted plate. Okay. So now we will write down the design strength of unbolted plate is equal to the design strength of unbolted plate. Strength of unbolted plate. Unbolted plate means there is no hole in plate. Any total strength of your plate, you can say. So what happened? The value will be, you can write on P, PD, unbolted plate equal to 0.9. Here, unbolted means gross area of plate, into Fu divided by gamma M1. If I write the values, so this is 0.9 into gross area is nothing but, if I write gross area per pitch length, यानी P into T. P हमारा कितना 40 into T, T कितना है हमारा 8 mm. तो ये क्या हो गया 832 यानी 320, 320 mm square. I'm right? 832 ना 320. So I write here gross area is 320 into Fu is 410, gamma MB is 1.25. So you will get this value of strength of unbolted plate is nothing but 0.9 into 320 into 410 divided by 1.25. It is nothing but 94 64 Newton. If you write in the kilonewton, that is 94.46 kilo. Okay. Now the last part of our example, we have to find out the efficiency. Efficiency is nothing but it is denoted by eta is nothing but strength of voltage joint, strength of voltage joint per pitch length divided by strength of unbolted plate per pitch length into 100 in percentage. Okay. So, the strength of voltage joint, you find out it is the value is 51.43 kilonewton. I will write here 51.43 kilonewton divided by strength of unbolted plate per pitch length is 94.46 into 100. So your efficiency of voltage joint will be 1.43 divided by 94.46. It will be 0.54 into 100. That is equal to 54.44%. The efficiency theta is equal to this. So you have asked in the example only two values: strength of joint, strength of voltage joint, strength of voltage joint, is equal to, here it is coming VDPV strength, that is the minimum. This value is the minimum. In above calculation, that is 51.43 kilonewton. And you have to ask the strength efficiency. Efficiency, that is eta is equal to 54.44%. इसी तरह अगर आपको स्ट्रेंथ ऑफ बोल्ट पूछा, you can write out strength of bolt. This is additional. I am not counting the strength voltage value. Is strength of bolt, or it is also called as bolt value. अगर ये पूछा, it is the minimum of VDPV and VDSP. So here strength of bolt will be nothing but the strength of voltage joint, because again here VDPV is this, that is also 51 point. This one is the additional way I am showing to you. Okay. Now question number 7 for your assignment number 1. Write down question number 7 for assignment number 1. That is 372021. So let's write down this. I think so. You understand this today's example. कहीं पे कुछ प्रॉब्लम है तो आप पूछ सकते हो. Anybody? Anyone having
No,
anything?
sir. No, sir. No, sir.
No sir, no sir. तो आई होप सो आपको ज़्यादा समझ में आ रहा है और आप बराबर से फिर वो करेंगे. हाँ,
सर क्वेश्चन नंबर 7 बताइए ना.
बता रहा हूँ ना बेटा. राइट है. क्वेश्चन नंबर 6 फॉर असाइनमेंट नंबर. Question number 7. Calculate the bolt value of single cover, single cover, single cover, single bolted butt joint the thickness of main plate is 12 mm. Main plates are 12 mm and over plate is 10 mm. Use steel of grade Fe 410 grade of gold 4.6 diameter of gold 22 mm. Okay, so you have to calculate this. Uh, Calculate the bolt value. You have to find out the bolt value. So I think so. This example, take a screenshot. Is question number 7. Question number 7. Take a screenshot. Okay, I think so. You are written all these things. Hmm? So
Yes, sir.
very good. And I will also share on your WhatsApp group and the sheet. हैं? So we will stop here.